Welcome guys, welcome back to another video of Study We Like. In this video we will be decoding the periodic table. So let's begin. Before studying the chapter we should learn about the prefaces. First we have to state the role of Mendeleev played in the early development of the periodic table. Second, highlight, label and locate groups, periods, blocks, metals, non-metals and metalloids in the periodic table and describe the patterns and trends in the periodic table. Now we will learn who was Mendeleev. In 1869, the Russian chemist Dmitry Mendeleev produced one of the first practical periodic tables. His work laid the foundation of the modern periodic table. The most amazing part is that Mendeleev's table of elements left spaces for the yet to be discovered elements. We will also discuss that the scientists before Mendeleev had grouped elements based on their common properties, like being a gas or a highly reactive metal, or they were grouped based on their atomic mass. Mendeleev saw a way to combine the two approaches, atomic masses and the common chemical properties, into one simple table. Now we will learn about the characteristics of the Mendeleev's periodic table. Some of the characteristics are: Mendeleev arranged the elements according to their increasing atomic mass. Mendeleev did not include noble gases in his periodic table since they were discovered later, and his version has columns for groups and rows for periods. Now we will learn about the modern periodic table. There are 118 elements in the modern periodic table. The elements are arranged according to their increasing atomic number. Each box contains one element. Now let's learn that what is a period. A period is a row of the table. Rows run horizontally. There are 7 periods in the modern periodic table, as you can see in the diagram. And the two rows below the periodic table are lanthanides and actinides, collectively called the inner transition metals. Lanthanides are often called the rare earth elements, whereas actinides include mostly artificial elements with a few exceptions. Now let's learn that what is a group. A group is a column of the table. Columns run vertically. There are 18 groups in the modern periodic table. Groups 3 to 12 are sometimes labeled as transition metals and referred to as D block. As we can see in the table, the numberings 1 to 18 is established by IUPAC, but the most important modern periodic tables use the conventional Roman numeral plus letter combination. For example, group 1 is also labeled as group 1A. Groups 3 to 12 belong to group B, while group 1 to 2 and 13 to 18 belong to group A and known as representative elements. Now we will learn about the metals and non-metals. Metals. First we will introduce metals. They are good conductors of electricity and thermal energy. It has high density, it is malleable and have high melting points. The elements marked in green is known as metals in the periodic table. Now we will introduce what are non-metals. Poor conductors of electricity and thermal energy. It has low density, it is brittle and have low melting points. The elements shown in the periodic table marked in purple are known as non-metals. Now we have learned both about metals and non-metals. Now my question is to you that what are the elements indicated in yellow in the periodic table? The answer to the previous question is they are metalloids. The properties of metalloids can be similar to metals and non-metals. They appear to be more like non-metals but have some properties that conduct electricity, so they are called semiconductors. Silicon, germanium are useful in many electrical devices. Now we would learn about the periodic trends. Periodic trends are repeating patterns found in the modern periodic table as you move across a period or down a group. One periodic property is effective nuclear charge. It is a measure of the ability of protons in the atom's nucleus to attract the electrons in orbit around the edge of an atom. Now, how would the nuclear charge change as you move across a period? We can say that the effective nuclear charge increases across a period since the number of protons increases. On the other hand, it decreases down a group because of increasing number of shells. Now, in relation to the nuclear charge, the atomic size generally decreases as you move across the period. Consequently, the atomic size increases as you move down the group. As the number of electron shells increases, there is a larger distance between the nucleus and the outermost orbital. Now we will move on to our next periodic trends, that is the reactivity. As you descend group 1, the reactivity of elements increases drastically. This is due in part to the effective nuclear charge. Group 18 elements are also known as noble gases. They are very stable due to their filled valence shells and are less likely to react with other elements. Now we will try to summarize all the points to which we have learned by now. That Dmitry Mendeleev, he produced one of the first practical periodic tables. His work became the basis of modern periodic table. And the outcome, final outcome, that is the modern periodic table, it has vertical columns called groups and horizontal rows called periods. Its arrangement allows us to look for patterns in the properties of the elements. With this, we are marking an end to the chapter decoding the periodic table. So guys, I hope you have enjoyed our video. If you truly liked our video, please do like, share and subscribe our channel Study Be Like, and please share with others, and thanks for watching till the end. Thank you.